What is a 3D vector? Whether you need good help, a genius writer, a brainy tutor, or a data analyst, Intudo4U has them all. It's like having a research dream team, on demand. And if you are new here, then subscribe now for more amazing video just like that.
All right, so let's dive right in. What exactly are these vectors that are basically running the show behind the scenes? Okay, so what even is a vector? Well, to get it, you first got to understand what it's not. It's not just a plain old number, what mathematicians would call a scalar. A vector, see, it's so much more. It packs in a ton more information. It's a quantity that answers two really crucial questions. How much, that's its magnitude or its size, and which way, and that's its direction. Think of it like this. A scalar, like speed, just tells you how fast you're going. Say, 100 kilometers an hour. Cool. But a vector, like velocity, tells you both how fast and in what direction. 100 kilometers per hour north. And believe me, that extra bit of information about direction, it changes everything. And when you see one drawn out, it's literally just an arrow. The length of the arrow is its magnitude, the how much. And the way the arrow is pointing, well, that's its direction, the which way. Super simple concept, right? But incredibly powerful. Okay, but this is where things get really interesting and honestly, a little weird for a lot of people when they first learn this stuff. We're going to talk about multiplying vectors, specifically using something called the dot product. And this confusion is captured perfectly by this question somebody asked online. It gets right to the heart of the problem. There seem to be two totally different ways to think about the dot product, and it is not obvious how they're connected. See, on one hand, you've got this super straightforward calculation. You just multiply the matching parts of the two vectors, the x's with the x's, the y's with the y's, and so on, and then you add them all up. Simple, right?
Before we start, let me quickly tell you this. If you ever feel stuck with your graphs, reports, or data analysis, you don't need to struggle alone. At Intudo4U.com, you'll get step-by-step guidance from expert writers, tutors, and data analysts. Whether it's learning about 3D vectors, creating professional graphs, or completing research projects, Intudo4U is here to help you succeed. I'll explain in simple words what a 3D vector is and why it's so important in data visualization, physics, and math. Backhand index pointing right example. Imagine you're describing the flight of a drone. The x-axis shows movement left to right. The y-axis shows movement up and down. The z-axis shows movement forward and backward. Now, a 3D vector is just a way to represent this motion in all three directions at once. It's written as XYZ, so every point or direction in space can be captured by a 3D vector. For example, a vector 3, 2, 5 means moving 3 steps along X, 2 steps along Y, and 5 steps along Z. This makes it super useful for describing positions, velocities, and forces in 3D. Artist palette how to make it attractive in graphs. Heavy checkmark use different colors for X, Y, and Z axes. Heavy checkmark draw the vector as an arrow starting at the origin and pointing to X, Y, Z. Heavy checkmark rotate the 3D view to show the arrow's full direction. Heavy checkmark add a grid or markers to highlight exact points. This makes your explanation not just informative, but also visual and engaging. Lightbulb for more help with 3D vectors, graphs, or data analysis, visit backhand index pointing right Intudo4U.com. And don't forget to like, share, and subscribe for more tutorials on vectors, plots, and data visualization.